Welcome to qnawire.
In this problem, we're using the conservation of angular momentum to deduce the velocity of a bullet before it strikes a disk that is free to rotate about an axle at its center. The mass of the disk is 1.6 kilograms. The mass of the bullet is 0.02 kilograms. The radius of the disk is 0.6 meters. And once the bullet strikes it tangentially and becomes embedded in the wheel and starts to spin, the wheel is spinning at 4 radians per second. So in order to find our v here, all we need to do is apply our conservation of angular momentum. There are no external forces acting on the system, so we can just set these equal to each other. So our original angular momentum is all going to be the bullet because the wheel is stationary. So the angular momentum of this bullet is going to be I omega, IB omega. And of course, the bullet being essentially a point, it's going to have a moment of inertia of mr squared, mb for the bullet, times the initial angular velocity, which we're going to put in terms of v naught. So it's going to be v naught over r. And right away, these can cancel. I'll cross them out so that they're still here, though. Okay, so we have that side of the equation. Now we can find the angular momentum of the system after the collision takes place, which is going to be, once again, I guess I1, omega 1. We know what omega 1 is, so we're going to keep that out front. And I1 is going to be the moment of inertia of the disk plus the bullet on the side, since it embedded itself there. So, whoops, this shouldn't be an equal sign. So this will be times moment of inertia of the disk plus the moment of inertia of the bullet. And we know what the moment of inertia of a disk is. We already know what the moment of inertia of the bullet is. So we can simplify this down a bit more. MBR V naught is equal to omega 1 times moment of inertia of the disk, 1/2 mdr squared plus mbr squared. Now all we need to do is rearrange this, simplify it, and bring out the v. We can do that, of course, by dividing by r, but first I'm going to pull out this r squared so we can just cancel that. R squared times md over 2 plus mb. And now this can cancel with that. And then all we need to do is divide through by mb. And we will get v naught is equal to omega 1 r over mb times md over 2 plus mb. Or if we distribute that, omega 1 r times md over 2 mb plus 1. And then all we need to do is plug in our numbers. This will be 4 times the radius, 0.6, times first the mass of the disk, 1.6, over 2 times the mass of the bullet, 0.02, plus 1. And that will get us our initial velocity of 98.4 meters per second.